How do heat exchangers work in thermodynamics? Have you ever wondered how heat can be transferred from one fluid to another without them ever mixing? This is where heat exchangers come into play. Let's break down how these fascinating devices operate within the principles of thermodynamics. Heat exchangers are designed to transfer thermal energy, or heat, between two or more fluids, which can be liquids, gases, or vapors. The key here is that these fluids do not mix. The process relies on fundamental thermodynamic principles, especially the transfer of heat from a hotter fluid to a colder one until they reach a balanced temperature, known as thermal equilibrium. At the heart of this operation is the zeroth law of thermodynamics, which tells us that temperature is a measurable property. The second law states that heat naturally flows from a higher temperature body to a lower temperature one. The first law, which is about the conservation of energy, ensures that the heat lost by the hot fluid equals the heat gained by the cold fluid, minus any minor losses to the surroundings. Inside a heat exchanger, the hot fluid flows through one section while the cold fluid flows through another. These two sections are separated by a solid barrier, often made of metal tubes or plates. Heat transfers from the hot fluid to the cold fluid through this barrier. This happens through two main processes: conduction, where heat moves through the solid material, and convection, where heat is carried by the movement of fluids. As a result, the hot fluid cools down while the cold fluid warms up. Heat exchangers can have different flow arrangements. In parallel flow, both fluids move in the same direction. In counterflow, they move in opposite directions. There are also cross-flow arrangements. Each configuration affects how efficiently heat is transferred and the temperature changes of the fluids. When designing a heat exchanger, several key parameters are considered. These include the temperature difference between the fluids, the heat transfer surface area, and the overall heat transfer coefficient, which measures how effectively heat passes through the materials. There are common types of heat exchangers, such as shell-and tube and plate heat exchangers. In shell-and tube designs, one fluid flows inside tubes while the other flows around these tubes within a shell. Plate heat exchangers use thin plates to separate fluids, allowing for efficient heat transfer over a larger surface area. Heat exchangers are widely used in various industries, including power generation, chemical processing, heating, ventilation, and air conditioning, refrigeration, and food processing. They allow for efficient heating or cooling of fluids by transferring heat without mixing them, which is essential for maintaining the integrity and performance of many systems. In essence, heat exchangers work by transferring heat from a hotter fluid to a colder fluid through a solid barrier, using conduction and convection. This process is guided by the fundamental laws of thermodynamics, ensuring energy balance and temperature change without mixing the fluids. Understanding how these devices function can help us appreciate their critical role in many thermal systems.